Okay, so take a look at these two girls. I can't say for sure that they're practicing pure programming, but I'm pretty sure that they're pairing. Pair programming is one of the fundamental practices in one of the forms of Agile called extreme programming, or XP. And it's one of the practices that is becoming highly valued by growing numbers of hiring managers. So I'm Ron Lichty, and I'm going to introduce myself in a minute, but I want to know who you are first. So how many of you are educators? All right, 201, excellent. So how many of you teach in classrooms, students in classrooms? How many of you teach students remotely, electronically? About half. So everybody teaches in classrooms, about half of you teach electronically, over the net. I'm here to speak in the role of programming hiring managers everywhere, actually. I want to thank all of you for teaching all of those students to program. This is a wonderful thing. I'm your customer. In a sense, I'm one of the hiring managers who hires your students. 30 years ago, I became a programmer. I wrote embedded microcontroller devices. I wrote compilers. I wrote early word processors. I wrote entertainment software. I wrote multimedia software. We had several patents. I wrote a couple of books on assembly language programming for personal computers, which dates me enormously. 24 years ago, Apple Computer offered me my first management role. And I spent 7 years at Apple. I bounced back and forth between being a programmer and being a manager at first until they finally convinced me that I wanted to be, that I should be a manager, and I convinced myself that I wanted to be a manager. And I spent the last 3 years there managing the development of the Macintosh UI, the desktop, the core of the Apple experience, so to speak. I have since then managed, I've since then almost exclusively managed. I have managed programmers, project managers, product managers, and testers in companies ranging from tiny startups to the Fortune 500. And I have managed small teams as a manager. I've managed as a director. I've been a VP of technology, a VP of products, and a CTO. And a few months ago, Addison Wesley released my fifth book, a book on managing programmers and managing programming teams called Managing the Unmanageable: Rules, Tools, and Insights for Managing Software People and Teams. There are a ton of books on project management, as all of you know. There are scores of books on every single project management style available. There are a ton of books on managing. There are very few books on managing programmers. One of our books been getting, it's actually, there are probably only 6 or 7 books on managing programmers. And it's been getting, since it was released in October, it's been getting a fair amount of acclaim. It's been compared to the Mythical Man Month by 3 separate reviewers in the last month. All of you, I presume, know the Mythical Man Month, published in 1975, 250,000 copies in print. Still selling very well, and the classic in software development and the challenges in software development. My co-author and I decided to write this book partly because we had been collecting rules of thumb, and I'm going to share some rules of thumb with you. So I want to bring this up now because I'm going to share some rules of thumb with you about Agile shortly. We had been collecting rules of thumb, and both of us started collecting rules of thumb because one of the rules of thumb that kicked us off was Fred Brooks from Mythical Man Month, Brooks' Law, which probably all of you recognize. When a software project is late, Adding manpower will make it later. Rules of thumb are those pithy, short, tight statements that represent reality that you can share with your colleagues or with senior management. It gets them around to understanding what it is that you understand. And that was what we were doing. And so we ultimately share, there's a whole section of these 80 pages in the book that represent 300 rules of thumb from that we collected from managers around the world. One of the other drivers that led Mickey and I to write this book, and it's an opportunity in education because since both of us found becoming managers hard. Neither of us had had any training in management. And I've talked, since the book has come out, I've talked to a lot of managers. And to an audience, I find that half of managers, of programmers and programming teams, half of managers have never had a single day of training in management. Half. And of the half who've managed, who have had training in management, who've had a single day of management, it's a really tiny number who had that training before they became managers. There's a huge opportunity there. And so that's not what I'm here to talk to you about, but I thought I would share that with you because Mickey and I made it our mission to share what we had learned and the rules of thumb that we collected, but it's a real opportunity in education. So in the 8 years that it took us to write this book, I've bounced back and forth between managing software organizations and consulting with organizations in implementing best practices and training organizations in implementing best practices, of which 4 of those are Agile: Extreme Programming, Scrum, Kanban, and Lean. And those are best practices that are hard to come by in industry. They are hard to find for hiring managers. And so that's what I want to talk to you about, and that's where you come in. So the topic of this conference is doing what matters for ICT education. And the Community College in California Collaborative talks about enabling students to meet ICT workforce needs. So I thought about that, and as I've been in MPICS thanks to Elaine Haight here, I got recruited to be part of MPICS advisory group, and it's led me to think about what would be wins for community colleges as far as I'm concerned, as far as a hiring manager is concerned, as far as managing programmers. And it comes down to 3 things, I think. One is having your students in demand in the workplace. One is having industry filling their hardest to fill needs with your graduates and students. And the third is your ICT programs lauded for their quality and their relevance. And so that's what I propose talking about today. Now, achieving those 3 wins, experienced programmers always have advantage over new graduates of experience. No matter how good your faculty, you're going to teach them programming skills like Java and C++ and C# and maybe Scala or Ruby or Clojure or one of the newer languages. And despite that, experienced programmers will win out. Except we are at an inflection point in software development. We've been through several of these before. We went from functional programming to object-oriented programming. And we are now at an inflection point where it's an inflection point for agile processes, practices, and frameworks. 2 decades ago, agile experiments began changing the face of software development. Last decade, that became a movement. This decade, it's a groundswell. And the number of hiring managers who are looking for people who have experience with Agile is mushrooming way faster than the number of people who can fill those. So I was going to show you, I was prepared to show you a long listing of job listings that call out the demand for Agile, but this came out from eWeek just last week. James had this in his, brought this up in his keynote yesterday. The title is Agile Developers Needed, Demand Outpaces Supply. To quote the opening, the number of available Agile jobs outnumbered qualified candidates by nearly 5 to 1 over the last 2 years, according to a study by Yo Services. So I want to read you a few of the data points from this article. The need for qualified Agile developers has skyrocketed. The number of available Agile developers cannot keep up with demand. Many of the Fortune 500 and leading brands in America are increasingly searching for Agile software developers that can help them improve speed of delivery and provide more and better value to their customers. This skills gap has not only made it difficult for companies to quickly source quality talent on demand, but also puts them at risk of hiring technical professionals that have poor Agile methodology skills. Washington and California, states with a more severe gap, have 10 open positions for every candidate. The adoption of the Agile development methodology has accelerated since the latter part of the last decade. Training for frontline developers failed to keep pace. Organizations that get available experienced talent are forced to pay premiums where others are forced to hire and train professionals on Agile methodologies. I do training in Agile for companies. I see this frequently. And finally, Agile developers hold all the cards. So Agile practices transitioned last year from being emerging to being dominant. And at the same time, it's not just the what. It's not just those languages. It's not just C++ and C# and Java and the languages. It's the how. That how is really important, and it's what you need to realize is the extent to which hiring managers will look beyond the what if you can provide the how. If your students can say, we not only learned, but practiced and experienced and used practices like Scrum and test-driven development and pair programming. So there are problems with Agile.
Question?
Yes.
I mean, I've taught test-driven development in my classrooms and stuff, but some of the terms you're using actually don't even have a firm grasp of what they are.
So I'm going to come. Let me come around to that. If that's the.
Because you said that you started with the problems with knowledge already. I was thinking, but go ahead.
Yeah. So I'm going to start. Generally. I'm going to come down to some very specifics, and then if I haven't answered your question, ask it again. So the problems with Agile is not only that there are too few practitioners, which one out of 10 jobs, 1 out of 5 jobs. It depends on where you live, but it sucks as a hiring manager. But bad habits. But it's really hard to change the existing workforce from using the old methods to using the new ones. Those old habits, it's a change that involves mindset changes and changes of habit. And those habits run deep. So if you are, and furthermore, if you are teaching students to work on their own, to put off testing, or worse, to give students so much confidence in their programming that they don't believe they have to test at all, or to accept requirements as gospel, not participate in eliciting and understanding them, then you're creating programmers who have the old skills, not the new ones. And those are skills that are to us as hiring managers faulty goods at this point. You're ingraining the very habits that we have to retool. So workplaces hit walls retooling programmers, and it's because they're so hard to change, and it's because test-driven development and pair programming and are change in habits. So while Agile has a reputation as being loose among some people, in my experience, it is the most rigorous methodology that I've run across, methodology, practices, and framework that I've run across in my 30 years of programming. And it requires change. And college is the place that we can change this, because those things aren't set yet. So the more that you can give us students who learned Agile practices because your curricula required them to use those practices, the better, both for your students and for us. So what are the practices we hire for? So Agile is too big a word. When I'm looking down a resume, I tend to skip over the word Agile because it sort of means everything these days. Scrum is not a bad word. It gives me some sense that I've got other questions that I can ask. It leads hiring managers to another set of questions that they can ask. So I want to do a poll of the room and ask you, how many of you give students experience working in teams? All right, so about 3/4. So how many of you teach your students to program tests before they program the code that's going to be tested, which is to say test-driven development? How many teach your students to work in pairs? Sometimes maybe, okay. How many of you teach your students to partner in requirements elicitation? How many of you teach collaborating with product owners around ordering requirements, around prioritizing requirements? How many of you teach rapid relative estimating? So in points or in t-shirt sizes as opposed to in days or in hours. Those are all Agile methodologies. So not only developing iterations, but developing products incrementally every iteration and delivering products every iteration. Retrospecting regularly and continuously learning. Practicing emergent design in the context of architectural road mapping. And demonstrating facility with personal time management might be in one method of which is practicing Pomodoros. So that's a lot to go from not a lot to some. So where do we start? So these are the two that I would start with. So when I'm looking at resumes, I'm combing resumes for that whole list, but these are the two that are hardest for me to get. They're hardest for me to train. They're hardest for me to retrain. They're hardest for me to find people who've got those skills. And I'll look at candidates at any level who've got that ability. So let me talk about test-driven development. So here's the test-driven development flowchart. You write a test before you've written any code. You check to see that the test fails because the code's not there. You write the code. You check to see that the test passes. And then you clean up the code. And in industry, you check in not only the code, but you check in the test, and the test becomes part of your regression suite that lets you repeatedly know that your whole body of code is continuing to work. Now, the cycle that this cycle is done at a very small level, a fine-grained level. That should take 30 seconds to 2 minutes for an experienced programmer. Write a test, fail, write code, succeed, iterate. 30 seconds to 2 minutes. So Rob Myers, who's who I think of as one of the gurus of test-driven development, I co-chair a number of special interest groups, and he came and talked to my best practices special interest group. And Rob was talking about, he had a 2-year team project to write a life-critical application. So this is an application that when organs are harvested, kidneys and lungs and hearts and those kinds of things, it identifies the person who is most in need of that at the hospital and the doctor, and it makes that connection in what's a matter of hours and sometimes minutes to get the organ to where it needs to go. That's a life-critical application. They spent 2 years writing this life-critical application using test-driven development. They ended up with 9,000 unit tests. 9,000 unit tests that could be run against their code in under 10 minutes. Didn't take them 10 minutes to write them, but they could run them against their code. What that meant was they could refactor their code, they could add a feature, they could change the code, and know in under half an hour that their program was still serving a life-critical need. They could have that confidence. Yeah.
So how do you define test? I'm not sure exactly what that is. I mean, so when I give an assignment, I always just sample out what the program should do. Is that defining test? Is that sufficient?
So it's using JUnit in Java. It's using I think it's JSUnit in JavaScript. It's using unit testing to test each individual feature. So at the front end, at the UI end, it's really hard to do unit tests. But at the core code level, it's very easy to write unit tests.
Right. I just say maybe using those tools, just having like what I described.
I think of it as writing the main first. You write the main, that's going to call methods or whatever, and then you don't have the methods yet.
Yeah.
So I just think of it, because I don't do it with JUnit, but I just make them write the main first, or sometimes I give them the main. So that, and in a beginning class, in a very beginning class where you don't want
to. You give them?
So
sometimes.
So Rob Myers, in the example I was giving you, was working in Java, and his team was using JUnit, and they were doing that cycle I described, that cycle there, and his time frame is 30 seconds to 2 minutes for each one of these. For each JUnit test feature, so it's not at a feature level. It's at a line of code level, line or a couple of lines of code level. And the result is this. This is one of those rules of thumb. There's evidence of doing TDD. This is from Mike Cohn, who wrote Succeeding with Agile. There's evidence of doing TDD takes about 15% longer. 15% is not very much. 15% longer, but there's also evidence that TDD leads to fewer defects. 2 studies at Microsoft found the number of bugs found went down by 24% and 38% with the use of TDD, test-driven development. That's huge.
Well, one other thing that I don't think you mentioned, and maybe I missed it, but one thing I do is and it's clear from the statistics that you mentioned, was that it's automated. And that wasn't clear, I think, in what you described. So I want to make sure that people understand that we're writing automated tests. So that
right, you're writing tests that can become part of a regression suite that can test that code over and over again as you add more code and make changes. That's right. That's right. That's right. And so it becomes part of continuous development, part of one of those other practices called continuous development, which allows you to release code into the delivery stream as often as you want, as often as you're done with it, as often as any programmer on your team is done with it. So this it has a bunch of benefits. It benefits product teams because it forces understanding of requirements. So I don't know whether you've noticed this or not, but programmers have the ability to write code without understanding what they're writing it for. But it's really hard to write tests without understanding what you're testing. And test-driven development drives understanding, because if you're going to write tests first, you have to understand what it is the requirements are. Elaine.
That's why I think the 15% longer, I think for our newbie beginning students, I think they save time by doing TDD. Because they're so unexpert, they don't understand the requirements at all.
That wouldn't surprise me at all.
And so they start writing some method definition. They have no idea what they're writing, and they start fighting with the compiler about this code that's not doing anything related to what I asked them to do. And they spend a lot of time doing that.
So it benefits product teams because it forces them to understand requirements. It benefits programmers because it allows well, one of the things that programmers find is they hate code that has gotten so crufty, it's got so much technical debt in it, that's so brittle and so hard to change. And they go to their managers and say, we want to fix this. We want to refactor it. We want to go in and rewrite parts of it and make it better. And managers say, it's working now. But that manager of that Rob Myers piece of code with 9,000 tests, they know that if they change that code and they rerun, as Ridge was saying, they rerun the compiler, they do a compile, and they rerun those 9,000 tests, they know that code's still working. And that's incredibly valuable. Now, TDD values students because they get to put test-driven development on their resumes, one, and two, they get to talk about how they used it in their classroom, in their teams, and they get to speak it. And they finish their homework sooner, even better.
I think they do, yeah.
In my world, the cost of retooling a team to do test-driven development is really hard. And it's really hard because what I find is that of programmers who've been working in the programming world, about 1 in 5 gets it. About 1 in 5 gets that whole concept of writing tests before writing code. You're at the point at which they don't get it because they think it's unnatural. You're at the point at which you can say the natural way to do this is to write tests, not code, is to implant the concept of natural being test first development. You're at that huge opportunity. So TDD is at the top of my list, and the result is that I think your students with TDD on their resumes, they've got an opportunity to deliver code quality that's as high as some of the better experienced programmers out there. Because there are some programmers out there who don't deliver very good code, and it's partly because of this. Who don't have, just giving them the acceptance of the responsibility for testing first, and secondly, that you're writing tests before coding.
Well, one of the problems I have is it wasn't on the outline you tested. I had the kids start with UML. This is first semester students I'm talking about.
Yeah.
So these UMLs are very small. One class. And then I have them write the Java doc. Because they need, in order to write the test, they have to have the specification.
Yep.
So I do UML, then I do Java doc, then I do test, then I do development.
Perfect. Perfect. I want to talk to your students. What I'm hiring. So the next thing is pair programming. So here's Martin Fowler, who wrote the book Refactoring. Martin Fowler is one of the gurus of Agile frameworks and process and practices. So the advocates of pair programming are advocates because they believe that a pair is actually more productive than two separate developers. This is due to the continuous discussion and review that pairing introduces. You come up with better designs, make fewer mistakes, make more people familiar with the codes, and all these things offset having less people typing. So why are less people typing? What's pair programming? It's two people typically sitting with one monitor, passing back and forth, one keyboard and one mouse. One's typing, the other one's watching. Now the interesting thing is, and I know managers who do this, We say you have a choice. You can either when you're done, we'll do a code review of your work, or you can develop it using pair programming. Because pair programming is code review. You've got the other programmers doing code review while you're typing. This is good practice. You don't have to go to a second code review as a result of doing that. And managers will let them off the hook for that reason. So pair programming is practiced by pairs. The girls at the beginning, these two guys here. It's been shown to be more productive, to be as productive, to have higher quality, but it's counterintuitive for many people unless they started doing it when they were the age of the girls or when they started doing it in your classroom. For those of you who are doing online or virtual work, it's actually slightly easier to do pair programming. And it's slightly easier because I've had teams doing this, and they'll bring up a virtual session. So they're both looking at a monitor on the same code. They're looking at the same, the same screen of code, but they've both got a keyboard and they've both got a mouse. It feels a little bit more natural, and they've got a voice connection between the two of them. It feels a little bit more natural, and really what it's about is developing the timing and how do we pass the cursor back and forth between the two of us. So the conventions. Yes.
Do you have information with tools for that?
Do we? Yes, and I can't. And I was struggling to name it off the top of my head, and I'm not doing it. Yeah, but there are Unix tools that bring up. There are Unix tools that bring up looking at the same screen, multiple people looking at the same screen at the same time, and there are coding tools that do that. What is it?
TeamViewer is one.
TeamViewer is one, and it's still not the one I'm trying to think of. So there are a bunch of them that do that. So these are practices that we hire for. If I were to follow with experience doing, if I were to go to a next one, I would go to Scrum, after test-driven development and pair programming. And I would go to Scrum because it actually takes in a bunch of the rest of these. So it takes in teams, programming in teams, takes in backlogs, takes in developing incrementally and iteratively, and incremental delivery and continuous delivery. It takes in sprints, it takes in planning, it takes in eliciting requirements collaboratively. So as well practiced in industry, actually. So it's interesting. You can go talk to companies and they'll say, oh yeah, we do Agile. We have daily stand-ups. Daily stand-ups are supposed to be 15 minutes and everybody's standing up, and they'll say, oh no, well everybody's sitting down in our company and they take an hour. So okay, so there are three fundamental questions that you ask in a stand-up. Really? So there's not a lot of understanding out there, and it's I said we're on this inflection point, and it's because we're at the buzzword level, but not the deep understanding level. And if you can bring your students to the deep understanding level, they will get a huge reception by hiring managers. So if everybody came out of your programs testing first and pair programming and knowing about the principles of Scrum and how to do it and how to do all that kind of thing, your students would be dramatically more hirable. Industry would not only snatch them up but be grateful to you. And your programs would change the tenor of programming in your regions. I really think that, with regard both to quality and to productivity. So you have more hirable students, grateful industry, and programs that change quality and productivity across your region. Win-win-win. So that's, thanks again for the opportunity to think together about, and I'll turn it to questions, to think together about how to do this hard thing we call software development. So, did I answer your questions, Rich?
You mentioned yesterday to me, so I haven't answered, I haven't talked to you yesterday.
Yeah.
I've got these 3 questions that you just mentioned associated with Scrum, but what you do yesterday, or the obstacles, what are you going to do tomorrow, if I remember correctly.
Yes.
So, can you define more what Scrum is for the benefit of all of us? Or is that it? I mean, is that...
So I teach teams Scrum in a day and a half or 2 days, and that's not sufficient, but it's a taste of what Scrum is. The essence, there are a couple of essences of Scrum. One, it's working in teams of 5 to 7, 7 plus or minus 2 actually, so 5 to 9. It is a group of developers and a Scrum Master and a product owner. So there are defined roles. The product owner is thought of as a product manager, brings what the requirements are, and understands them and is in communication and sits with that team. That's a team that all sits together. The Scrum Master you might think of as a project manager, but they're not running the project. Scrum Master's job is to facilitate and to remove obstacles. So in that daily stand-up that they have, so this is a whole iterative thing. They're developing in what are called sprints, which last somewhere between typically between 2 weeks and 4 weeks, and it's a fixed time for every team. So the team says, okay, so our sprint length is going to be 3 weeks. At the end of every 3 weeks, they deliver code. They deliver working code. It may or may not be delivered to customers, but it's delivered to the product owner, and the product owner gets to decide whether it's delivered to customers or not. At the end of every sprint, it is demoed to the product owner. And at the end of every sprint, the team has what's called a retrospective. And they together talk about what went well, what didn't go well, and what 1 or 2 things they're going to do differently in their next sprint to be better. So they're looking at learning and at growing and at improving. Let's see, what else am I leaving out? So the daily stand-up is like a daily iteration inside of that sprint length iteration. Daily iteration, it's an iteration because each member of the team answers those 3 questions. What did I say I was going to do? What did I say yesterday that I was going to do by today? Did I accomplish that or not? What's standing in my way? Well, no, the second thing is what am I going to do by tomorrow? And then what's standing in my way, either with what I said I was going to do by today or what I need to do by tomorrow. And so you've got that daily iteration, and that's a meeting that should take less than 15 minutes. That's why everybody's standing, and it answers only those 3 questions. The Scrum Master's role is to stand there and to listen for those impediments, and to listen for, oh, Bob and Sally have a dependency. Let's schedule a meeting for right after this for Bob and Sally to talk about Bob's dependency on Sally's code. And so the whole stand-up only takes 15 minutes, but there's a follow-up 15-minute meeting for the 2 of them to have a conversation about their dependency. The Scrum Master is listening for risks and dependencies. Elaine.
Does the Scrum Master also keep track of, Joe, you said you were going to finish this by today. Yesterday stand-up, you said that you finished this, and now you didn't finish it.
It's the team's responsibility to do that.
The whole team keeps track of what you said you were going to do.
Yes. So all of this may be scribed, may be brought up on a whiteboard. You've got one of the elements of Scrum is that you've got a task board, either virtually or real. And if you've got the team in the same room, I highly recommend doing it physically. So a task board here would have, if we use this whiteboard as a task board, we'd have here's the backlog, here's this sprint's backlog, here's what we're working on now. So when I start working on something, I, as a programmer, walk up, take that task, and move it under the what I'm working on column. And when I'm done with it, during that daily stand-up, I walk up and move it over to done, or to QA, and then it gets moved to done. There may be a QA or two QA people who are part of that, 5 to 9 people who are part of the Scrum team. The value of having, when it's physical, it's called an information radiator. Everybody can walk past this board, and I invite you to Google task boards, because you'll find a bunch of pictures of task boards if you do the image search on Google. And what you find is that everybody in the company can walk by this task board and know exactly what's going on. It delivers transparency. So one of the aspects of Scrum is it delivers transparency. Everybody knows, everybody on the team knows what's going on. Senior management can come wandering by and know what's going on as well. And it's very tactile. So a programmer walks up and actually moves a task from one spot to another. There's a sense of accomplishment of doing that with your team. And one of the interesting red flags for Scrum teams is if in that daily stand-up, 9 people standing around in a circle, if the conversations are all between each team member and the Scrum Master's not doing it right. Because the conversations need to be between each individual team member and the rest of the team. This is a team thing. It's not there's the whole notion of Agile and of Scrum bubbles up from it's a grounds up programmers owning code kind of thing. And so this is a change it's a change from tell me what to do to I'm going to take responsibility to do this. Walking up to this board and saying, this is mine. I own delivering this and moving it. And so that's another piece of that cultural change that makes it that some teams leap for and others have a really hard time getting to because they're used to being told what to do.
I haven't ever done the Scrum stuff in my classroom. I've never done the Scrum stuff, etc. But I can imagine doing it. And as you know, one reason I came to this talk was to say, well, how do I, manage my course to take advantage of this? And Elaine's been involved with, problem-based learning, scenario-based learning. And so in the first half of the course, we kind of all do it the same. We're teaching. This is teaching first-year students. We're teaching syntax, because we have to do that for working. The second half, though, we go with more problem-based approach. We meet twice a week. So the question is, do you think that 2 times a week? I mean, we can also do a lot of learning stuff, but the students have trouble, reading up with each other. So, in 2 times a week in the classroom, with these 15-minute segments where they do this stand-up thing, is that sufficient, or is that just not going to work?
So for your purposes, it's probably sufficient. There are Scrum teams. There are Scrum teams that are distributed. So there have been 2 very interesting and challenging and contraposed trends that have happened in the last decade and a half. One of them is Agile, the other is distributed teams. I typically am managing teams that are located all over the world. Sometimes it's because part of the team is outsourced to Colombia or India or Eastern Europe. Part of the time it's a team that there are no 2 people in the same city anywhere in the world. And it gathers virtually. All of those teams gather virtually. All of those teams gather virtually, and this whole Agile idea is we're all going to sit together face to face, and so that when I, as a programmer, come across an ambiguity in the requirements, I can look up and say, what does this mean to my product owner who's sitting there with me? So it's a huge challenge. I should tell you one other aspect of Scrum that I think is Scrum, in particular and Agile in general, that I think is really valuable, which is that whole backlog idea is that backlog. I talk to programmers a lot, and I will ask them, how many of you have gotten a 400-page set of requirements? And almost every hand in the room will go up. And then I'll ask, what percentage of those requirements did you actually deliver? And outside of the ringer, so once in a while I get somebody from NASA who will say 97%. Outside of that, the numbers I get typically are in the 15 to 25% range. They deliver 15 to 25% of a 400-page set of requirements. Now, what that means is that 75 to 85% of the time that the product manager spent writing 400 pages of requirements was waste. And 75 to 85% of the time that programmers spent trying to understand those requirements was waste. And 75 to 85% of the time that the testers spent developing test plans was waste. And 75 to 85% of the time that the project manager spent developing a project plan to deliver all 400 pages was waste. Scrum is about, let's write each feature or each use case or each user story onto a card or a sticky, and we've sort of got a headline for what that is. And we'll put them all in this backlog, and then it's the responsibility of the product owner to order them, to give them priority. And the order is generally based on, there's a couple of factors that come into it, which is technical risk and technology challenge and technical debt. But the major one is customer value. They're ordered by customer value. And the team says, we can tackle. We start at the top. This is the most customer value. We've got 3 weeks that we're going to do a sprint. We can tackle these stories. We move them into our sprint backlog. This is what we commit to delivering 3 weeks from now. And the team knows. The team knows that it's always working on the highest customer value. Always working on that. And sales can go out and have this conversation with a customer and come back and say, wow, it just changed. The requirements just changed. What customers care about just changed. And that's fine. The team is locked and loaded for 3 weeks. They're going to deliver this stuff. And that backlog, left of the sprint backlog, the general backlog can totally change every 3 weeks. Sales and marketing can totally change that every 3 weeks. Unlike a 400-page set of requirements.
I got about 3 minutes.
Okay. So other questions?
The task force, sorry. So looking at the bad habits that you have in the first one, what are your techniques? I guess in 1 minute that would be done.
So so what I tend to emphasize changing bad habits is benefits. I look at the carrot rather than the stick. And the carrot with test-driven development is, if you do test-driven development, you've got a regression set of tests that you can then convince management to go in and refactor that whole body of code in the in-between, or after you just delivered version 1 and it's time to get to version 2. You've got that opportunity. And programmers crave that. Pair programming it's sort of a combination of stick and it's I'll point you a choice. We'll do a code review of your code, or you can do pair programming. And not every programmer, for not every programmer is pair programming going to work. I mean, I love that picture of the girls at the start. They're so engaged with each other. Like the picture of the 2 guys there. Very engaged with each other, but that doesn't work for everybody. All right, a last question.
Can you repeat what practicing Pomodoros is?
Pomodoros is a form of personal time management that says, I'm going to shut everything else out for the next period of time. And you set a time. There are a couple of books on Pomodoros. The sub period of time typically is 20 minutes, and I'm just gonna do something for 20 minutes, and I'm gonna shut out everything else, and I'm not gonna be interrupted, and then I'm gonna take a break for 5 minutes or 10 minutes before I start the next Pomodoro. And Pomodoro is named after their egg timers. They're also timers. They're in the shape of apples, and Pomodoro is the name for apple in Italian, I think. Okay.